So one of the exciting things about having the same Minister for Statistics and for Land Information is that you start to be able to think about putting together the power of what is happening with the power of where it's happening. And a lot of the examples that I gave in my previous presentation were about things at places, about information that Stats has lived and dealt with for a very long time, but hasn't taken as precise an approach to exactly where and presenting exactly where as we needed to do in the earthquake recovery. I was really excited to come to Wellington a couple of weeks ago, 3 weeks ago, after getting a request from the open data community in Christchurch, which said the stats data on census is really exciting, but can we get it as live geospatial feeds? Because the mesh blocks and NZ Stat are great, but we've got to recombine stuff that you might already have. And I said, well, I don't know. I know Stats is doing some fantastic stuff around geospatial, so maybe they'll be able to provide an answer. So I think that's one of the number of things that Rochelle and Eli are going to be covering today was the answer to that particular question. And I was pretty pleased that we got the answer a lot faster than I thought we might have. So really pleased to introduce Rochelle Morgan and Eli Chadwick from the Geospatial team at Stats. Over to you.
Right. Work out how to change slides. Whoops. Easy. Cool. So I've seen a few elephants in the room over the last couple of days. Here's another one. So this explains why a presentation on data sharing can attract such a wide variety of people who approach data sharing from their own perspective, whether it's policy or a technologist, a user or a producer of data, some kind of data or information. So I'm kind of going to try and cut across a wide variety of things with a geospatial angle, and even if some of the concepts might be unfamiliar to you, hopefully you'll get something out of it. So I'm going to give you some idea of what we at Stats are doing in the geospatial area, so hopefully you can make more use of our data, and also as well, maybe you'll get some benefit of sharing your own data that we may use in an administrative sense someday. And then we're going to hear from Trish from Eagle Technology, who's going to show you some reuse of our data that we have done. So, over to my notes. So as you've probably heard a few times in the last couple of days, we're the leader of the official statistics system, and our job is to give you information that you need to grow and prosper for New Zealand. We aim to provide data that's relevant and accessible and trustworthy, and this holds true for our geospatial information. So we are part of a wider system, and we're intrinsically linked to open data and the New Zealand Geospatial Strategy, which if you're in the last session you would have heard all about. Because actually location is quite relevant to New Zealanders, because they identify with where things are and with their communities and with their cities and towns. That's what makes sense to them. So Geospatial at Stats New Zealand is all about trying to facilitate the integration of statistics and geospatial information so that we can actually increase the value and relevance of our statistics by linking the socio-economic information to location. So we call this spatial enablement. So over the last couple of years, we've been increasing our capability in building an infrastructure so that we can use and exploit GIS technology. We aim to spatially enable our statistics and also our statistical processes so we can become more relevant for our users and also to become more efficient. So one component of this infrastructure is the statistical spatial framework. This is essentially the mechanism to spatially enable our data. We need core fundamental spatial data to underpin most of what we do, which we're working closely with Land Information New Zealand to try and help make open and available. We need to geocode our data so we can manage it spatially, and we need to manage our geographic areas that links our geographies to our statistics, and the standards and governance that provide you with assurance. So don't tell the statisticians in the room, but much of our statistical data is actually already spatial. We don't always think of it spatially, or manage it spatially, or analyse it spatially. We produce a large number of tables and, big tables of numbers. Many of our tables actually have a reference to place, a mesh block, an area unit, or a region, or even the country. We can make a lot more use of this tabular data if we link it to our geometries and visualise it and analyse it in a spatial way. Not just at the output stage, but also through the whole statistical production process. So spatial enablement is about unleashing the power of spatial analysis, and it's not just about making pretty maps, but maps are very pretty to look at. But that's the cool stuff that I'm not going to show you. I'm going to pass that on. So if you haven't seen this before, this is basically a diagram of how all of our geographies relate together. Our core geographic function at Stats has been traditionally to maintain mesh blocks and all of the higher geographies. So we have a steward or a custodian role in all of these geographies. Some of the areas are quite grey, and there's some historical things we need to tidy up. For example, the mesh block is the basic statistical spatial unit. It's the building block from which everything else is created. But we don't actually own the digital. We don't actually have the digital official mesh block copy of in-house. That's actually held at LINS. So that creates problems for us to keep it up to date and maintained. So we've got some work with LINS going ahead to transfer that custodianship. And also a lot of our statistics are often released at the green and blue kind of levels, which are administrative and electoral areas. The orange, that don't look that orange, but that's supposed to be orange, boxes are our statistical geographies. So they're the ones that actually relate to concepts that make sense to people. So things like urban, rural, communities, that kind of thing. So our statistical geographies are getting quite out of date, and we've got a project on the go to improve them. So yeah, we're keen to hear from anyone that wants to be a stakeholder. I'm going to swap the next two slides around if I can. Okay. So if I asked you to draw a map of New Zealand with your pen and paper, I think everyone's map would look quite different. Mine wouldn't look anything like New Zealand, by the way. So if you take a statistic, say like this one here, which is the Mackenzie area unit, how do you know what part of the country that actually applies to? So the Minister gave the example of Kaikoura yesterday. This is the same kind of thing. So the Mackenzie area unit extends all the way from Lake Benmore to the top of Mount Cook, but it actually excludes Tekapo, Twizel and Fairlie. So that may not actually be evident straight away, and so when we release data in a table, it can be taken out of context. So we need to tighten up the link between the statistics that we release in a table and the actual geography that it relates to, because we can't actually separate the understanding of the information without thinking about what the geography is. So until recently, in a not very open way, we make our users, particularly our GIS users, do all the linking themselves. This is a really high transaction cost for our users that we unknowingly passed on to them for many years. Now I need to go backwards. So, over the past couple of years, as I said, there's been a lot of effort putting into building an infrastructure that will enable us to maintain our data spatially and build services to visualise and share it. We are introducing automation to the boundary maintenance process, which until recently has basically been managed by exchanging bits of paper with lens and drawing changes with pink highlighters. That no longer happens that way, by the way. We've been building our capability and in some cases losing it just as fast, but that's another story. We're also actively involved in setting standards in collaboration with LINZ. So projects like the Canterbury SDI's Property Data Management Framework project is dear to our heart because we have a lot of issues around locating people and we want that to be more efficient. So we're actively involved in the New Zealand Geospatial strategy. Right. So users have our geographic boundary data has actually been available for some time. For around the last 20 years, you've been able to get digital boundaries downloaded from our website or available in whatever other means. In 2008, we made these free. We used to charge tens of thousands for them. So you can download them from our website in a variety of formats and plug them into a GIS. But these are just boundaries. Until recently, there's actually been no statistics attached to them. So users have had to try and link up the information themselves. We also now have an interactive boundary viewer, which is down the bottom there. It's where you can actually visualise our boundaries on the web and muck around with them that way. So Stats' main mechanism for releasing data or to view and download information is nz.stat. So these are really large data sets where you can select variables and customise your layout and download them in Excel or CSV format. So someone yesterday was talking about how that's quite an interactive human process. So in December we released our StatsMac product, which Eli's going to show you soon. But for us, we're joining up data and we've discovered a whole lot of difficulties with doing that. So we're discovering all the hassles that our users have had for many years, basically. So things like, for example, what do you do when you've got text values in a field because the cell's confidentialised or suppressed? That just doesn't work on a map. We've got geographic codes that are codes, so they're text, but the Excel converts them to numbers or whatever. We have leading zeros that get truncated. We have labelling that doesn't really work on maps. It's a whole lot of things to kind of smooth out to actually get the statistics linked up to a geography. And Eli's going to show you some examples of where we've done that. So this might seem like a bit too much detail for a presentation like this, but my point is that data sharing has costs. So we incur costs preparing the data, and users can incur costs formatting it at the other end. But we need to be conscious of where those costs lie and open up the data as much to minimise it. So we're working really hard to do that at Stats in the geospatial area, and now I'm going to pass you to Eli to show you the cool stuff. See, there you go, the cool stuff.
Kia ora koutou, my name's Eli, I work at Stats in the Geospatial team, and I'm going to show you the cool stuff. I'm actually tasked with explaining simply how we do data sharing geospatially, which is a big call for an afternoon session last day of the conference, but I'll try and keep it light and fluffy and follow I'm actually going to follow through a help desk call that I took a couple of days ago, which illustrates exactly why data sharing is so cool. So I got a call from a guy, I'll call him Dave because we're all about anonymity here at Stats, and Dave was a geospatial analyst based out of Auckland. He'd been tasked with putting together a coverage analysis map to work out whether they were hitting a KPI of 75% of the population. To achieve this, he needed our area units data, and he needed the actual boundaries, and as Rochelle's just explained, this has a high overhead of having to attach them, and he had to have this report out by 5 o'clock that afternoon. So first he'd have to download it all, it's never going to happen. Around the turn of the century, we would have probably not serviced this request, but had we attempted to, it would have involved taking a cut of the data, burning it onto a CD, and then probably popping it into the post and sending it off to Dave, and he would have been sadly in trouble come 5 o'clock that day. Geospatial data is notoriously large. To describe all these boundaries is you've got to describe every little vertice. So as you go sending it around, you need tons of bandwidth. Back in, as I say, back around the sort of early 2000s, the internet was much slower and quite expensive, which made it not feasible to send your data around in this fashion. So roll forward to the present, internet is now faster, cheaper, and much more widely available. So it makes data transfer and downloading of files quite a feasible approach. So back to Dave. I've got Dave on the phone, and he's in trouble. And I might be too. Oh, there it is. So, yeah, there it is. That's all right. So while I had Dave on the phone, I got him to go to our website. And so he came over to here. Then I got him to go down to this link right here, which takes you through to Stats Maps. Stats Maps is our landing page. It has all things mapping. It has all the maps that we're releasing. It has the viewer that Rochelle just alluded to, the geographic boundary viewer. So this viewer, interestingly, is a viewer that only has, maybe I'll try it. It only has the boundaries. It doesn't actually have any statistical data attached to it. So it's sort of so that people can work out where all our boundaries are. And while that loads, there it is there. So there's no data behind any of these. These are just simply, it's a tool to allow people to visualise where exactly all our boundaries are. We've got all the mesh blocks loaded up and area units, anything they'd like to see. However, Dave needs data. And Dave's now wondering, why am I cruising around showing him my maps? The map that Dave actually needs is down here. It's the population and dwelling mobile map. No, not that one. This one. So this is the data that Dave needs. He needs data at an area unit level, and he needs people counts, because he's got a network map that he's going to lay over the top, and then he's going to do a spatial query and say, am I hitting 75% of New Zealanders? If so, I've met my KPI. If not, we need to do more work. So the next step was to take Dave back to the landing page. Back. And over here under advanced, just quietly hidden down the bottom, is our catalogue. So once I got Dave to click on the catalogue button, I heard silence, and then you beauty, quote unquote. Dave knew what this was because Dave's an Esri user. Stats New Zealand is also an Esri user. This is powered by ArcGIS server. So as soon as Dave saw this page, he thought, oh great. And he basically said, thanks a lot, see you later. This is a beautiful thing for a help desk call because I don't have to explain anything. This is common knowledge to Esri users. It's simply a catalogue showing where all our data is. These are all web services available for use in any application. So if you've written an application you want to use our data, simply link to, for instance, you want the 91 boundaries. That URL is all you need. You drop that into your web mapping application and up come the layers. You have to do a bit of coding, but c'est la vie, life's difficult. So that's all good news for people that want boundaries. However, if you're Dave, he very quickly saw this folder and went, oh great, here is the census data. So what we have here is, it's called a REST endpoint. These are all the layers. This is the layer that Dave needs. You come down here, there's the schema. It shows you all the fields that are in the data, so you already know what it is you're going to get. And being a GIS professional, you're most likely going to know how to interact with it. And so, yeah, goodbye, Dave. Off he goes. Life is good. In this, so essentially what we have here, and this is where it gets a bit sort of techie, I apologise, but what we have here is a series of map services that are published out of Arc Server. They come in, there's one foundation service, and then it's wrapped up in many different ways for different users. There's REST, so that's your RESTful interface. I won't even start to explain that. Here's SOAP, which is the sort of more old school XML approach. A lot of people still use it now. It's on the way out, I believe, and REST will be the new way. It's just my opinion. And then down here we have two more of interest, the WMS and the WFS. What these guys are is the SOAP interface allows you to connect your Arc desktop application to it, but if you're not lucky enough to have an Arc desktop application, you're going to have to use some other vendor's piece of mapping software. The only way that they can connect to our services is through these WMS and WFS. They're OGC compliant, so anybody that plays the OGC game is going to play nicely together. And now if I go back up to, oops. If I pop back up to home, and then I in fact want to go back to stats maps. If I back in this way, go back here and go back to the population and dwelling map. If I click on an area, here's all the data. What you're essentially seeing there is data sharing in action. This is a HTML5, so just a normal web site, and it's connecting to our web services by JavaScript, and it essentially hits that map service URL, pulls all the data back, and then throws it on the map. So what we have here is, you'll hear the story of the boundaries need to get attached to the data. What we have here is the boundaries, and when you click on them, there is the data that's been attached to them. And what we've actually done in this map is made it time series, so you can go back through time and look at changes over time. And you can drill down deeper and look at different layers. So that's regional council, aggregated data, territorial authority, area unit. And so the area unit data is the one that Dave's interested in. So down at area unit level, we can click on Pencaro, there's all the information. So yeah, at a really high level, he's just going to take his network map, lay it over the top of this one, and then do analysis. So if I go down here, we have usual resident population. What this little guy does is creates, it's called a choropleth. No one knows what that is though, so it's a more commonly known as a thematic. At Stats we love plain English, so we've called it select a variable to compare across areas, just so as to not confuse the general population. But what it does is it's showing a thematic distribution of the population at area unit level. So essentially, when he lays his network over the top, he better hit the dark green bits if he wants to clock up his 75%. And so that's really, in a nutshell, how data sharing works. And to answer Julian's question earlier, he was saying, I hope you guys are about to serve your data out in a geospatial feed. Yes, we are. And just briefly before I finish, I'd be remiss not to mention Scott Tansley, who we procured from Julian. And while I was chatting to him in a sort of a professional sense, he was explaining how he'd been through this painful process of having to stitch the data to the boundaries many times, and how Stats wasn't exactly playing the SDI game nicely. And so I suggested, why don't you come and work for us and we'll sort it out? And he said, yeah, sure. And so here we are. Thank you, Scott. He's done a magnificent job, and I'm here to carry on his legacy. So, yeah, that's all from me for now. Thank you.
Thanks, Eli. I just wanted to commend Stats on all this wonderful work that they've been doing. When this newest census was released, I was just, me myself as a GIS professional, was ecstatic at how easy it now is to connect to these services and start making really valuable maps, much easier than it was before. So yeah, great work, guys, and it's really exciting times to be a GIS professional with this sort of data at our fingertips now. So for those of you who don't know me, I'm Trish Mertz, and I'm a location analytics consultant at Eagle Technology. So Eagle, like Eli said, are the New Zealand distributor for Esri software, and it's the same software that Stats uses to produce all of their maps and web services. So Rochelle and Eli invited me along, and they said, hey Trish, why don't you come and show the audience some of the cool ways that organizations are using stats information to produce some really valuable information products. And today I'm going to show you some of those, specifically those involving a map. So I'm going to start over at the left with a bit of a fun example. So this is a tongue-in-cheek map produced by the New Zealand Herald that shows social behavior patterns normalized by population counts. So we can see those areas of the country that are the most gluttonous, or that feel that they have a certain level of importance than others. No surprise, Auckland is up there in the rankings. Sloth, wrath, and all of those 7 deadly sins. And this is using a variety of different information, health statistics. This one's using crimes, and that's normalized by population counts and then displayed using the regional boundaries from Stats New Zealand. So that's quite a fun one. So this map is a visualization where we can start to see through this chloropleth map where different patterns are. And that's really the power of a map, is this visualization. Another example I have of some powerful visualization. This map is produced by Map Data Services over in Australia. So this isn't actually using New Zealand census, but this is using the Australian Bureau of Statistics services to produce a risk layer. So this map is showing those regions in Australia that are at higher risk of bushfires. Now, while this is an Australian example, this same sort of work is done in New Zealand by all of the insurance providers. And this is really important in determining policies. So for different areas, different neighborhoods, what is the propensity to flooding, to earthquake risks, et cetera. So this has a really important implication on policies, and a lot of times this is normalized by population and often visualized by the various statistic boundaries as well. So this is visualization. We then move to how maps can be used to measure, to quantify things. So this is an example of a web map produced by QLDC, the Queenstown Lakes District Trust. And this map measures the number of liquor licenses across town, again, normalized by population in mesh blocks. So this is a really important map to a number of different stakeholders in Queenstown. Of course, the police can use this map to understand where to distribute their resources. Also, the local council would use it for planning purposes, for things like looking at noise complaints, looking at perhaps where they want to implement public liquor banned areas as well. And this is done by taking the number of licenses and then aggregating them by these population, these mesh blocks. So moving on, we can then look at how maps can be used to look at trends over time, or look at how areas are related. So this map, if I start the animation, this map was put together by the Canterbury Development Corporation, and they, like we heard from Julian earlier, use the business data from Stats New Zealand, in this case to show historic employment levels over time. So maps like this, I'll just zoom into Christchurch, perhaps we can see some of the patterns in there a bit better. So employment trends have a number of implications. They can be used to ensure resources and business decisions make sense both given current employment trends and also looking at historic employment trends as well. So clicking on one of these areas, we can see, for example, in the CBD, that employment dropped significantly in the CBD, of course, after 2011 because of the earthquake. So this, of course, has implications in terms of where businesses themselves decide to set up, and then what services need to be provided to support those businesses. Next, I'd like to move on to look at a commercial example. So what we're looking at here is, if I click on one of these areas, we're looking at resident counts, and this is just pulling in one of the web services that we saw from Eli. Now I'm going to zoom in to Wellington in here, to the northern suburbs, and turn on one of my layers here. So another way that maps can be used is determining the best location. In this case, we're looking at the location of two supermarkets, Countdown in Tawa and Countdown in Countdown in Poirua. So large format retailers often need a base population in order to sustain business. So before they decide to set up shop, they'll do some analysis in order to determine whether or not there's enough population in an area to actually sustain business. So what large format retailers do is they'll derive some sort of catchment area. Here we're looking at a catchment area which is defined as a 5-minute drive time from each of those supermarket locations. And then what we can do is we can overlay that information on top of demographic information. So in this case, I've overlaid it with some of the population counts. And we can immediately see the population base that we have access to within a 5-minute drive time from those supermarkets. So I'll just zoom the table over here. So you can see in this Tawa location, this is the new Countdown that just opened up there. They've got access to about 32,000 people. And this is an interesting location. It's actually, there's an Auckland developer who's currently in the process of getting planning put through Wellington City Council to develop a strip mall in this area as well. Up to this point, there hasn't been anything in that area, but certainly we can see just by this analysis that there's quite a large population pool close by to this location. So this is an example of how businesses, how organizations can take Stats New Zealand's demographic information, pull in their own business information, combine that with spatial analysis processes, and derive some valuable information products. So these are some quite visual examples. We've got some more examples over at our booth. So if you'd like to chat a bit more about what you've seen today or about how maps can perhaps help your organization to make some more valuable decisions, come and have a chat, and love to hear from you.